We know the look of the ideal pizza slice: a crisp golden crust that holds its shape, melted cheese bubbling at the surface, and distinct charred pepperoni cups holding tiny pools of savory oil. But when we try to replicate this at home, the results are often disappointing. The center of the crust usually turns out soft and soggy, while the meat lays completely flat, releasing grease across the top of the pie. Correcting these issues requires us to manage three specific mechanical variables: meat physics, dough handling, and the thermal environment of the oven. Professional results at home depend on mastering the physical reactions happening on the cutting board and inside the oven. The process begins with our baseline components. You need room temperature fermented dough, whole milk mozzarella, a thick sauce, and a whole stick of pepperoni. Most pre-sliced meat is skinless, which is why it stays flat when baked. To force the curl, you must use a stick with a natural casing, which contains the heat-sensitive collagen fibers necessary for structural transformation. Slice at room temperature between 0.9 and 1.1 millimeters. Freezing creates ice crystals that rupture protein structures, releasing moisture and inhibiting curl. During baking, the top surface dehydrates faster than the insulated bottom, creating a moisture gradient that pulls the edges upward. Once the cup forms, it traps the rendering fat within its rim. This prevents the grease from migrating across the pizza's surface and soaking into the dough. Because the edges of the cup are elevated and exposed to more air, they become thermal focal points that accelerate the Maillard reaction, producing a crispy char. By controlling the thickness and orientation of the slice, you determine how heat interacts with the protein and fat to achieve that specific texture. Step 2 is the mechanical handling of the base. Start with proofed room temperature dough placed onto a heavily floured work surface. Use your hands to gently press down in the center and move outward. This technique pushes the accumulated gas from the middle into the outer rim, creating the crust. As this side-by-side comparison shows, hand stretching leaves internal air pockets intact. Using a rolling pin crushes those pockets, resulting in a dense, heavy base. Transfer the stretched dough to a wooden pizza peel dusted with semolina flour. These coarse grains ensure the dough can slide off the peel with minimal friction. To prevent a soggy crust, we have to follow a specific assembly sequence. Begin by scattering grated mozzarella directly onto the bare, raw dough. Next, apply the pizza sauce strictly on top of the cheese layer rather than the dough. This cross-section highlights why this works. The layer of cheese creates an impermeable barrier that prevents the liquid in the sauce from penetrating the porous dough during the bake. Reversing the traditional order of ingredients ensures the dough remains dry throughout the cooking process. Step 3 is the bake. Your oven must be preheated to at least 500 degrees Fahrenheit with a baking steel inside for a full hour. Launch the pizza from the peel directly onto the superheated surface. The high floor temperature causes the gases in the crust to expand rapidly. Inside the oven, the cheese melts while the heat-sensitive collagen in the pepperoni casing shrinks, pulling the edges of the meat into a curl. For the final 60 to 90 seconds of the bake, switch the oven to the high broiler setting. This broiler hit mimics the top-down radiant heat of a commercial brick oven, finalizing the crust's texture and blistering the top of the cheese. Slide the peel under the crust to extract the pie. Rising steam and pools of rendered fat inside the charred cups indicate a successful bake. Place the pizza on a wire rack for a 5-minute cool-down. This allows the cheese to set and the starches in the crust to firm up, ensuring the slice maintains its structural integrity. We moved from raw components to an engineered finish by focusing on controlled slicing, on strategic layering, and maximizing heat transfer. Apply these specific variables the next time you prep for pizza night to achieve a consistent, professional finish from your home oven.